Hello, my dear students. Today, let us discuss some of the topics under your module 3, that is your second chapter or second unit, you can say, that is analysis on simple trusses. So, it comes under your module 3, analysis of simple trusses. So, I am Chandrakant, lecturing on my channel Civil Knowledge. It is basically used for the second sem students of engineering. Okay, let us go through the chapter. So before analysis, let us know about the introduction of the trusses. So what is this trusses? How we should analyze them? How the load will act on the trusses? Okay, what is the basic thing we should know about the truss? We will see in this chapter. So a truss is a structure made up of slender members, pin connected at ends, and is capable of taking loads at joints. So basically, a truss is a structure made up of slender members. Slender members means very thin members, which are pin connected. Their connection one to one member is by pin connection. Pin connection may be a riveted or bolt connection. It may be there. Okay, so it is connected by pin connection and is capable of taking loads at joints. So the loads are taken by the joints, not by the members. Okay, here we have to see, we will go through detail when we solve the problems. Okay, so a truss may also be called, defined as, a truss is an articulated structure with hinged or ball and socket joints. Okay, I'll show you the picture so that you can understand clearly. So it is an assemblage means it's a jointed. Okay, it's an assemblage of slender bars fastened together at the ends by smooth pins or balls and socket joints acting as hinges. So where the connection is done now, it's also called as hinges. Okay, at hinges only the load is taken care of. So let us see some pictures. So see here, this is the truss. So these steel members which I am moving the cursor, no, this is a truss. So basically a truss stable form is a triangle one. If the slender, if these members are connected in the form of a triangle, it is more stable one. So we will discuss in next chapters when we go through them. Okay, here is the bridge you see here. So these are the connected members are all truss members. So here these are all the truss members. So in this also you can see the truss members. See here. Okay, these truss members, almost all the steel structures which we see in our day-to-day life are basically a assemblage of these truss members. So we'll see what are the types of, means types, it's not type but we will classify them. Okay, what is this plane truss? A truss in which all the members lie in a single plane. Okay, a assemblage of slender members which are jointed by pin connection. If they all lie in a single plane, it is called as a plane truss. Okay, example, roof truss or bridge truss. Any steel structure if you saw means, above the structure there will be a roof, and the roof, almost all the roof which are coming these days are constructed by the steel that is in the form of truss. Okay, it is called as roof truss. So you can see an example for the picture. So see here, wall will be there, so it is the roof truss. Okay, on the workshops if you see above, you can see this type of structures. Okay, next one is space truss. So space truss will be like this. So a truss in which all the members do not lie in a single plane, okay, is called as space truss. If it is lie in the same plane, it's called as plane truss. If it does not lie in a single plane, it is called as a space truss. So for example, electric power transmission tower or microwave tower, etc., can be taken as example. Okay, don't go in detail but know about this. Now we will classify the trusses. So classification of trusses we will see now. So there are three types of classific. The trusses are being classified in three types. That is perfect truss, imperfect truss, or deficient truss, redundant truss. Okay. So these perfect truss, imperfect truss, redundant truss are classified on the basis of equilibrium equations, which I'll tell you later. Okay, we will see now one by one what is perfect truss, what is imperfect truss, and what is this redundant truss. Okay, now perfect truss. So what is this perfect truss? So a truss which has got sufficient number of members to resist the load without undergoing appreciable deformation in shape is called as a perfect truss. So it is a truss which has got sufficient number of members. Its members are so stiff that it doesn't go under any deformation when the load is applied. So if the truss is in stable form, it is called as a perfect truss, so that no deformation is seen. Or a truss is said to be a perfect truss if it is satisfies the below equation. So one equation is there. Okay, m is equal to 2j minus r, or m is equal to 2j minus 3. Here m is the number of members, j is the number of joints, r is the number of reactions. Okay, this there are two equations, so these equations should be satisfied. If the equation is satisfied, if this m is equal to 2j minus r or 2j minus 3, so equilibrium conditions are 3, so we can take r value as 3 only. So if an equation m is equal to 2j minus 3 is satisfied, then it is called as a perfect truss. So with an example I will show you so that you can understand betterly. And this type of truss do not collapse under loading. So these are stable form of trusses. If m is equal to 2j minus 3, then it is a perfect truss which is sufficient, which has sufficient number of members and can undergo and cannot, it cannot undergo deformation, and it will resist the load which comes upon it. So examples of perfect truss are, see here there are three trusses, so a1, b, c. So here in this truss you see, so these are the slender members 1, 2, 3, or 1, 2, 3. These slender members are connected at the joints. See here, this 1, 2, 3, these are the joints which are connected by bolt or rivet. Anyhow, the connection is pin connection. Okay, so here with the support is hinge, here the support is hinge, and here it is roller. Okay, so it is supported somewhat. Then we have to see whether this is a perfect truss or not. For that we have the equation, that is m is equal to 2j minus 3. Here members are 1 member, 2 member, 3 member. So the truss member, the slender members are called as the slender elements are called as members, and the elements joining to a point is called as a joint. Okay, so m is equal to 3, this 1, 2, 3, m is equal to 3. What is the joints? 1, 2, 3. So m is 3, j is 3. So when I substitute in the equation m is equal to 2j minus r or 2j minus 3, what I'll get? M is 3 is equal to 2 into 3. 3 is the j is 3. So 3 is equal to 3. So it satisfies the equation and it is a perfect truss. Okay, if it satisfies the equation, it's called as perfect truss. So we'll come to another example, that is b1. Here you see so many members are there. So first we shall calculate the members, elements. So 1, 2, 3, 4, 5, 6, 7, all the slender elements I calculated. Now these slender members are connected at a point, so that connection has to be established. No, so that connections are 1, 2, 3, 4, 5. Okay, so joints are 5, members are 7. So when I put in an equation, so see here m is equal to 2j minus r. So m is 7, 2 into j is 5 minus 3. So 7 is 7, it is satisfying the equation, so it is a perfect truss. If it gets loaded here at 2 point or 4 point, it will not undergo any deformation, it resists the load, so it is called as a perfect truss. So in this example also, m is 9, j is 6. So when we go through the, or when we apply the equation, it will satisfy the equation, so it is called as a perfect truss. Now we shall see what is this imperfect or deficient truss. So all is based upon that equation. If it satisfies the equation, it is perfect truss. If it is greater than or if it is smaller than, what will happen, we'll see now. So imperfect truss or deficient truss. A truss is said to be imperfect or deficient. Deficient means what? It lacks something in it. Okay, deficient or imperfect. Okay, a truss is said to be imperfect or deficient truss if it has less member than required for a perfect truss. If a truss member whose members are less than that are required, means what? The truss is unable to take all the loads which come upon it. It will undergo deformation. Why it is going under, why it is undergoing the deformation? Because it doesn't have the required member to resist the load. So such members are called as imperfect truss. So it is less than the so how we will define the deficient truss? A truss is said to be imperfect or deficient truss if it has a less member than that required for a perfect truss. So the equation will be m should be less than 2j minus 3. The equation for imperfect truss is m should be less than 2j minus 3. That is, the member should be less than the this 2j minus 3 or 2j minus r. Okay, r is nothing but 3, because there are three equations of equilibrium. I already told you in the chapter equilibrium of forces. In that chapter I already told you. So if the number of members are less than, you can also define like this: if the number of members are less than 2j minus 3, then it is called as an imperfect truss or deficient truss. So where m is the number of members, j number of joints, and r is the number of reactions. Okay, this type of truss collapse under loading because it doesn't have a member so that it can resist the loads. So because of it is lacking a member or lacking less number of member, it will collapse under loading and they are not stable. Okay, I'll show some examples. See here. So this is a truss. Okay, see here, one member, two, three, four. So four members are there. So it is four members are jointed by 4 points. 1, 2, 3, 4. Okay, so what are the members? Members are 4, joints are 4. So r is 3. So equilibrium reactions are 3. Okay, so when I input the equation, so m should be less than 2j minus r or 3, then number of members is 4, then joints is 4, 2 into 4 is 8, 8 minus 3 is 5. So number of members, so 4 is less than 5. When the members are less than the relation 2j minus r, then it is called as an imperfect truss or deficient truss. Okay, if it is less, it is called as deficient truss. If it is more, then what we call, we will see next. So next one is redundant truss. So what is this redundant truss? A truss is said to be redundant truss if it has more member than that required for a perfect truss. So deficient truss has a less member, redundant truss has a more member than required. Okay, if it has a more number than required for a perfect truss, it is called as redundant truss. So the equation should be m is greater than 2j minus 3. M is greater than 2j minus 3, where n number of members, m is number of members, j is number of joints, r is number of reactions. Okay, when the members are more than that are required for a perfect truss, then also the truss will, the this type of trusses does not collapse under loading. Okay, but it is redundant, so m should be greater than 2j minus 3. So in the civil field we require the economy. So economy tells us the whichever building we build should be economic and also it should be strengthful. So when this the much, when the members are stable enough, when the members are there that resist the load, if some members are there, if three members are there to resist some three loads, then it is enough. We shouldn't give another members to give extra strength. It should be, it will be waste. Okay, so here we'll see economy like that. That mindset will be there in this field. So for example I'll show you. So see here, just calculate the members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So members are 11, joints are 1, 2, 3, 4, 5, 6. So members are 11, joints are 6. So obviously members are more than the 2j minus r. So when I substitute the values, so see here m is greater than 2j minus r, so 11 is greater than 9. Okay, when the members are more than that are required for a perfect truss, then it is called as redundant truss. Okay, so these are the classification of trusses which are based on the equation, that is m is equal to 2j minus r. Next we will see the assumptions made under this truss. To solve problems we need to assume something, because in reality is different and practical is different. So here some assumptions related to the truss are: the ends of the members are pin connected or hinged. The members which are connected to each other are connected by hinge or pin connected. The load acts only at the joints, and here the load which comes on the truss member will not be on the members, it will be on the joints. So whatever the reaction after the action of forces is taken into account at the joints, not on the members. Self weight of the members are negligible. Okay, here, because when we take the large truss, here self weight of that members are negligible, we will take as negligible. So cross section of the members are uniform. Here in the truss we always maintain a uniform cross section, but in reality the members are connected by bolting, riveting, or by welding. Okay, so the ends connected are hinged only, but in reality we connect with the bolting, riveting, and welding, which gives an not accurate, but at least it is approximate to the accurate, means it is nearer to the accurate value when we do the analysis. Okay, which we'll do it later and we'll discuss there. So these were the assumptions. Next we'll see the nature of forces in the members. So when a truss is there, some load is applied on that, so how it reacts to that load, what is the reaction for the action of the load, we will see here. So the members of the truss are subjected to either tensile or compressive forces. Any truss members, if anyone asks you what are the forces that is experienced by a truss, you have to tell only two, that is tensile and compression. So only two forces are subjected, that is tension and compression, on these truss members. A truss is held in position by the supports and the loads are applied only at the joints. So a truss is held in position by the supports. So at the supports it is held by the truss members, but the loads are applied only at the joints. So yeah, whatever the load it may acted upon, the loads will be at the joints. The free body diagram of a member shows that it is acted upon by two equal and opposite forces. So if we take the free body diagram, if one triangle form truss is there, we have to take free body diagram of a member, so that it should acted upon two equal and opposite forces. This point I'll explain in the problem. Okay, when we cut the truss, so there will be two equal and opposite forces to, so that it can remain stable. Okay, the hinge joint permits members to rotate with respect to each other, and hence the members are subjected to purely axial force. So this hinge joint permits member to rotate. Okay, hinge pin connected members are free to rotate with respect to each other, and these members are subjected to purely axial forces. Okay, purely axial, these were the nature of forces, I'll tell you. So see here, this is a one type of truss. So a b c d e, so ab is a member, bc is a member, cd is a member, ae and ed members are there. Okay, so joints are a b c d e. Okay, when this type of trusses are loaded, so at e we can see the load. Okay, see here, if it is a member, if this see, this bc member is taken here. Okay, so on this force a compression is there. So on the member I am telling here. See here in AE form, whenever the load is applied, okay, you see here, this is the tension member which is came out. Okay, here the member is acted upon tension, that is from both side it is drawing, whereas an upper portion BC portion C, from both side it is pressing. So any pressing force is compression. Okay, and any drawing force is tension. So these are the forces in members. Okay, so whenever the truss is acted upon by the load, ಯಾವುದಾದ್ರೂ truss it is acted by the load. So in members you can see the tension force which is drawing towards opposite to each other, and compression force towards each other. Okay, compression force press ಮಾಡ್ದಂಗೆ ಆಗುತ್ತೆ, tension force draw ಮಾಡ್ದಂಗೆ ಆಗುತ್ತೆ, but these forces are in members. ಸೊ ಮೆಂಬರ್ಸ್ ಅಲ್ಲಿ ಈ ತರ ಫೋರ್ಸಸ್ ಇದ್ದಾಗ, ಸೊ ಅದನ್ನ ಕೌಂಟರ್ಆಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಇಂಟರ್ನಲ್ ಫೋರ್ಸಸ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಟು ಕೌಂಟರ್ಆಕ್ಟ್ ದೀಸ್ ಫೋರ್ಸಸ್ ಇನ್ ದ ಮೆಂಬರ್ಸ್ ಅಂಡ್ internal force will generate, and those internal forces are nothing but the forces at the joints. So see here, this in the member there is a tension force, but when we show in the joints, see here, the tension will be like this. Tension is towards each other, means in the members they are coming towards each other, but at the joint they are going away from each other. So to this reaction, internal reaction is this. So the internal tension will be shown as this, and for compression at the hinges can be shown by this. So at the hinges, the what I am going to say is, ಹಿಂಜ್ ಇದ್ದಲ್ಲಿ ಅಥವಾ ಪಾಯಿಂಟ್ಸ್ ಇದ್ದಲ್ಲಿ, ಈ ಪಾಯಿಂಟ್ ಇದಲ್ವಾ ಹಿಂಜ್ ಇದೆ, ಎ ಒಂದು ಹಿಂಜು, ಈ ಒಂದು ಹಿಂಜು, ಈ ಹಿಂಜ್ಗಳಲ್ಲಿ ಇಂಟರ್ನಲ್ ಫೋರ್ಸಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತಲ್ಲ, ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ನೊಟೇಶನ್ ಚೇಂಜ್ ಆಗುತ್ತಲ್ಲ. ಸೊ ದ ಜಾಯಿಂಟ್ಸ್ ಅಥವಾ ಜಾಯಿಂಟ್ಸ್ ಇಂದ ದೂರ ಹೋಗೋದು ಅಂದ್ರೆ ಮೆಂಬರ್ಸ್ ಒಳಗೆ ಹತ್ರ ಬರೋದನ್ನ ಏನಂತೀವಿ, ಟೆನ್ಷನ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸಿ ಹಿಯರ್, and here see, away they are going away from each other, means this is called as compression. So the scenario changes here. Okay, in members it is different, in joints it is different. Whenever a members experiences the tension force, that is drawing force, the internal reaction will be opposite to each other. So the hinges will be in tension, but the notation is like this. Similarly, when the compression force is experienced by the member, the notation for the hinges will be like this, that is away, that is going towards that point, wherever the tension is going away from the point. So this I'll tell you in the problem. So when I do the problem, you will understand correctly. So see here, tension member. So in member you can see the tension is like this, it is going away. Okay, see, and in compression what will be the compression is also, it is in the member. So this is tension member, so this is drawing away from each other. This is compression member which is coming together. ಓಕೆ, ಈ ಫೋರ್ಸು ಎರಡು ಹತ್ರ ಬರ್ತಾ ಇದೆ, ಫೋರ್ಸು ಇಲ್ಲಿ ಫೋರ್ಸ್ ಎರಡು ದೂರ ಹೋಗ್ತಾ ಇದೆ ತಮ್ಮಿಂದ. ಸೊ ಇದನ್ನ ನಾವೇನಂತೀವಿ, ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಅಂತೀವಿ, ಇದನ್ನ ಕಂಪ್ರೆಷನ್ ಮೆಂಬರ್ ಅಂತೀವಿ. ಬಟ್ ಹಿಯರ್ ಇನ್ ದ ಟ್ರಸ್ ಚಾಪ್ಟರ್, ಸೊ ಇದು ಮೆಂಬರ್ ಅಲ್ಲ ಆದ್ರೆ, ಓಕೆ, ಈ ಟ್ರಸ್ ಇಲ್ಲಿ ಹಿಂಜಿಗೆ ಏನು ಸಪೋರ್ಟ್ ಇರುತ್ತಲ್ಲ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಂಟರ್ನಲ್ ಫೋರ್ಸಸ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಇಂಟರ್ನಲ್ ಫೋರ್ಸಸ್, ದಿಸ್ ಇಂಟರ್ನಲ್ ಮೆಂಬರ್ ವಾಟ್ ಇಟ್ ವಿಲ್ ಡೂ, this tension force in this internal this tension force in this member will make the hinge. So I'll show you in the next slide. That is convection for internal forces, that is the action of forces in the members on the joint is as shown. So the tension is noted like this. So see here, two hinges are there. If it is coming towards internally, then it is called as tension. Where in the members, if this notation we see in the members, it is called as compression, but in the tension in the joints it is tension. See here, compression at the joints, however how it is going away. So this notation is used as tension in the member, but In the joints it is compression. So at the joint tension ಅಂತ ಹೇಳಿದ್ರೆ notation ಈ ತರ ಇರುತ್ತೆ. ಅದೇ compression ಅಂತ ಹೇಳಿದ್ರೆ notation ಈ ತರ ಇರುತ್ತೆ. So a joint is experiencing tension ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಆ ಜಾಯಿಂಟ್ಸ್ ಇಂದ ಫೋರ್ಸ್ ಹೊರಗಡೆ ಬರಬೇಕು ಈ ತರ. ಆ ಜಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಪ್ರೆಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ a truss should go inside the joint. A force member, the notation should be like this. Okay, so whenever I do problem I will again tell you how it is been happening, so there you can understand clearly. Okay, so see here the same example which I quoted in the behind slide, the back one which we saw now, that slide. So this, see here, see it is expressing compression, it is experiencing tension, right? So tension member is like this, compression member is like this. So see here, so to denote the compression in the member you have to denote like this. The arrow mark should be away from each other, and to denote the tension in the member which is going to be asked in the question in the problems, if we have to denote a tension in the member we have to denote the arrow mark towards each other. So towards each other it's called tension, opposite to each other it's called compression, but in the member scenario it is completely opposite. Okay, so sign convention used here. So positive sign is used for tension and negative sign is used for compression. So whatever I took the sign convention in the earlier chapter, same sign convention I am using here also. So clockwise movement is taken positive and anti-clockwise movement is taken negative. Okay, then so method of analysis. So what is the method to analyze this trusses? So we can find the forces in each member. In the problem we have to find the forces in each member, whether we have to tell the member is in tension or in the compression, the joints are in tension or in compression, so what is the force acting on it. Okay, so these type of analysis problems will be there. So there is a method for analysis. First method is method of joints, second one is method of section, and third method is graphical method. So here we are first year students, so we are only seeing the method of joints and method of sections. So graphical method is not there in our syllabus. If you want you can learn it from another textbooks. Okay, so in this chapter we will deal with the method of joints and method of section. So what is this method? I will go through it. So method of joints, so how it is done. So problem is given, one truss problem is given. Okay, you assume that one truss problem is given, what truss is there, a stable form of truss is there, on that loads are there. So because of that loads we have to find the forces in each member, and we have to tell the nature of the forces, whether it is tension or it is compression. Okay, when we solve the problem I'll tell you. So what is the method? So two independent equations of equilibrium can be formed. So two independent equations of equilibrium can be formed at each joint where the members meet and load acting to constitute a system of concurrent forces. Hence two independent equations of equilibrium can be formed at each joint. We have to select a joint, in that number of joints will be there, number of members will be there in that truss which is given as a question. We have to select where there are only two unknowns. We have to carefully analyze and we have to select a joint where there will be two unknowns. If there are two unknowns we can apply our equilibrium equations and we can find the one unknown, so it will be easy to carry out the problem to find another unknowns. Okay, then making use of the two equations of equilibrium at the joint, two unknown forces are found. So we have to select a joint where there are only two unknowns, and with that two unknowns we have, with that two unknown forces, by using two equations of equilibrium we have to find another two unknown forces, which is a corresponding process. I will tell you about this when we deal about the problem. And the next joint is selected for analysis where there are now only two unknowns. So if a joint is taken we will get answer for two unknowns. Next another joint will be taken, the two unknowns which are unknown here which will be known, and two another unknowns will be not known, and it is also using the equations of equilibrium, it is also be known. So thus analysis proceeds from joint to joint to find the forces in all the members. ಸೊ ಮೆಥಡ್ ಆಫ್ ಜಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, ಒಂದು ಟ್ರಸ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಟ್ರಸ್ ಮೇಲೆ ಲೋಡ್ ಇರುತ್ತೆ, ಪ್ರತಿ ಮೆಂಬರ್ ಅಲ್ಲಿ ಎಷ್ಟು ಫೋರ್ಸ್ ಇದೆ, ಆ ಮೆಂಬರ್ ಆಫ್ ಫೋರ್ಸಸ್ ಟೆನ್ಷನ್ ಕಂಪ್ರೆಷನ್ ಅಂತ ಹೇಳಿ ಕಂಡು ಹಿಡಿದಿರುತ್ತೆ. ಸೊ ಟ್ರಸ್ ಕೊಟ್ಟಾಗ ನಾವೇನ್ ಮಾಡಬೇಕು, ಕೇರ್ಫುಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಎಲ್ಲಿ ಒಂದು ಜಾಯಿಂಟ್ ಅನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು, ಆ ಜಾಯಿಂಟ್ ಅಲ್ಲಿ ಓನ್ಲಿ 2 ಅನ್ನೋನ್ ಫೋರ್ಸಸ್ ಇರಬೇಕು. ಓಕೆ, 2 ಅನ್ನೋನ್ ಫೋರ್ಸಸ್ ಇರೋಂಥ ಜಾಯಿಂಟ್ ಕಂಡು ಹಿಡ್ಕೊಂಡ್ಬಿಟ್ಟು ನಾವು 2 ಅನ್ನೋನ್ ಫೋರ್ಸ್ ನ ಇಕ್ವೇಶನ್ಸ್ ಆಫ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಬಳಸ್ಕೊಂಡು ಆ 2 ಅನ್ನೋನ್ ಫೋರ್ಸ್ ನ ಕಂಡು ಹಿಡಿತೀವಿ. ಸೊ ಆ 2 ಅನ್ನೋನ್ ಫೋರ್ಸ್ ನ ಕಂಡು ಹಿಡಿದಾಗ ಆ 2 ಅನ್ನೋನ್ ಫೋರ್ಸಸ್ ಇನ್ನೊಂದು ಕಡೆ ಜಾಯಿಂಟ್ ಆಗಿರುತ್ತಲ್ಲ, ಸೊ ವಿ ನೋ 2 ಅನ್ನೋನ್ ಫೋರ್ಸಸ್ ಅಂಡ್ ವಿ ಕ್ಯಾನ್ ನೆಕ್ಸ್ಟ್ ಶಿಫ್ಟ್ ಟು ದಟ್ ಜಾಯಿಂಟ್. ಆ ಜಾಯಿಂಟ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಾಗ ನಮಗೆ ಇಕ್ವೇಶನ್ಸ್ ಆಫ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಅನ್ನೋನ್ 2 ಬರುತ್ತೆ ವಿತ್ 2 ನೋನ್. ಓಕೆ, 2 unknown forces with 2 known forces will be there. ಹಾಗೆ joint to joint ಮಾಡಿ all the forces in the members are calculated and they are solved. So here by this way the method of joints can be analyzed. So when I am telling, you will not know it properly, so when I will solve the problem I will go step by step so that you can understand easily. Next one is the method of section. So as the name it indicates, so here the method of joints are basically solved by taking the joints, but in the method of sections it is also nothing but the method of joints. How we do the problem in joints, same way we'll do here, but we will give a section or we'll cut a part of the problem so that we will solve in pieces. So in this method we can directly determine the force in any member without proceeding to that member by a joint analysis. Okay, the method is as follows. So determine the reactions at the support of the truss given. Okay, any truss is given, so we have to determine the support. Take an imaginary cutting plane through the truss, dividing it into two parts such that it passes through the members in which forces are required. So we have to cut that truss member into two parts such that it passes through members in which forces are required. So where the forces have been asked, we have to cut that portion so that we can get we can calculate the forces at that point to solve this problem. The cutting plane should be taken in such a way that it cuts a maximum of 3 members in which forces are unknown. So the cutting should be done such a way that where we will cut the member, no, so that portion should be consist of maximum of 3 unknown members. Okay, now consider any one part to the left or right of the section and evaluate the unknowns by applying the conditions of equilibrium for the coplanar non-concurrent force system, that is summation of h equal to 0, summation of vertical force equal to 0 and summation of moment equal to 0. Okay, ಇಲ್ಲೇನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, so method of sections. So this method of sections is used for the truss which are in large ದೊಡ್ಡ problems. So there are so many of trusses ಇರ್ತಾವಲ್ಲ, ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಗೆ ಮೆಥಡ್ ಆಫ್ ಸೆಕ್ಷನ್ ಪ್ರೊಸೀಜರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, ಮೆಥಡ್ ಆಫ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಅದು ಉದ್ದ ಇರುತ್ತೆ, ಫುಲ್ಲು ದೊಡ್ಡದಿರುತ್ತೆ ಟ್ರಸ್ಸು. ಸೊ ಆ ಟ್ರಸ್ ಅನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ ಎಲ್ಲಿ ಅವ್ರು ಫೋರ್ಸ್ ಕೇಳಿದರೆ ಅಲ್ಲಿ ನಾವು ಕಟ್ ಮಾಡ್ಕೋತೀವಿ, ಆರ್ ನಮಗೆ ಎಲ್ಲಿ ಕಟ್ ಮಾಡ್ತೀವಿ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ 3 ಅನ್ನೋನ್ಸ್ ಇರಬೇಕು. ಸೊ ಅಂತ ಜಾಗ ನೋಡಿ ಕಟ್ ಮಾಡಿ ಐದರ್ ಲೆಫ್ಟ್ ಆಫ್ ದ ಸೆಕ್ಷನ್ ಆರ್ ರೈಟ್ ಆಫ್ ದ ಸೆಕ್ಷನ್ ಅನ್ನ ನಾವು ಅಲ್ಲಿ ಅನ್ನೋನ್ಸ್ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ with the conditions of equilibrium. Okay, that is summation of h equal to 0, summation of v equal to 0, summation of m equal to 0. By making this we will find the forces in the members and we will solve the problem. So both this method of joints and method of sections are easy, but they are lengthy. Both the methods are easy but they are lengthy. You should have patience, and with accuracy if you done means it will not go wrong and you can get full marks. Okay, so this was about the truss which I wanted to explain you. So I hope you understand. So this type of stress or this type of topics are well understood when we do some application problems. So when we do the problem one by one, the concept and the theory will go to our mind in deep, so that we can understand the topic better. Okay, thank you. So if anyone not subscribe my channel means, please subscribe my channel, that is civil knowledge. Thank you. I hope you understand.